If the given numbers are in the form of normalized floating point, then what I'm going to do? I'm going to add the number. If I consider addition, I have two conditions. One is overflow and another one is underflow. EA equal to M1 minus M2. So what is M1 and M2? M1 is nothing but true value and M2 is nothing but absolute value. Hello to all, a warm welcome to my new session on computer arithmetics. I'm Revati from the Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have covered in my last session. So dear student, in my last session, I started with definition of numerical analysis. Along with that, I have covered the advantages as well as disadvantages of numerical analysis. Along with that, the two approaches used to store real number, that is fixed floating point number and floating point number. Along with that, I have discussed the uses of numerical analysis. These are the three topics I have discussed in my last session. But in my today's session, I'm going to deal with how to add and subtract two floating point number. Along with that, I'm going to discuss errors in numbers. Along with, I'm going to solve some problems. So these are the certain topic I'm going to deal in my today's session. Anyway, dear student, let's start our session with the topic add, that is addition and subtract two floating point number. So dear student, how I can able to perform addition and subtraction of floating point numbers? So select two floating point number. What I want to do? I want to select any two floating point number, and what I want to do? Initially, I want to compare the exponent. So what I want to do? I want to select any two floating point number. Then I want to compare the exponent. Then what I want to do? I want to select only the highest exponent to align the mantissa. For example, I have number 1. In that, I have the power 3. And I have number 2 and power is 7. To perform addition, what I want to do? I want to consider the exponent. And which one I want to consider? That is the highest exponent. That means after adding number 1 and number 2, whatever the sum I'm going to get, and the exponent of that sum is my highest degree exponent. Perform addition of numbers. So after that, I'm going to perform the addition of numbers. So if two numbers presented in normalized floating point number are to be added, that means if the given numbers are in the form of normalized floating point, then what I'm going to do? I'm going to add the number. Add the exponent of the two numbers. That means I'm going to add the exponent of the two numbers must be made in equal and mantissa shifted approximately. If I'm going to have normalized floating point number, then what I want to do? I want to add the exponent of two numbers. So here I have some solved example. That is, think that I have example 1. So here I have 0.4546 exponent 5 plus 0.5433 E5. That is, I want to add 5, 4, 6 E5. My next number is 5, 4, 3, 3, E5. And what I want to do, I want to add. Okay, what is the rule? First, I want to consider the exponent. And both the number will have same exponent. So, what I will do, I'll write as it is. E5. Now, 6 plus 3, 9. 4 plus 3, it is 7. 5 plus 4, it is 9. It is 9 dot. So, what is the answer here? 0.9979 E5. Now, if I consider this number, see, here I have E5 and here I have E7. So, to make it normalized number or to make both the exponents same, what I'm going to do? I'm going to shift that number 2 bit right. So, what I'm going to do? I'm going to shift that number 2 bit or 2 digit right. See, what are the number I have? I have dot 4, 5, 4, 6, E5, and I have 5, 4, 3, 3, E7. Okay, fine. Now, see, if I consider the exponent, what is my first exponent? It is 5. And if I consider second one, it is 7. To make it 7, what I'm going to do? I'm going to shift my 2 bit towards right. So, what I will do? Dot 0, 0, 4, 5, 4, 6, E5 plus 2. There is nothing but E7. When my both the numbers are equal, that is, the exponents are equal, then I'm going to add the number. Now, see here, if I consider addition, I have two conditions. One is overflow and another one is underflow. So, dear student, if I add these two numbers, I'm going to get some value. And if I shift, see here, I have 1.1279 E99. Okay, to make it normalized number, what I'm going to do? I'm going to shift this number. When I shift this number, it becomes 11279 E100. That is exponent 100. So, here it is overflow condition. That means when my exponent is 100, then it indicates that it is overflow. Now, if I'm going to have above 100, for example, I have 110 or 105, that is E105 or E110, then it indicates that underflow. So, whatever the floating point number I have, in that if the given exponent is equal to 100, then it is overflow. More than 100, then it is underflow condition. Now, I have the rule for subtraction. The rule for subtraction is same as addition. So, what I want to do? First, I want to consider the exponent. Okay, see here, I have 0.9432E. From, I want to subtract this one. So, it is 0.5452 e to the power minus 3. Okay, so to match or to balance the exponent, what I'm going to do, see here, I have minus 4, exponent is minus 4, here I have minus 3. To make it balanced one, what I'm going to do? I'm going to shift this number. I'm going to shift this digit. Then I'm going to subtract. When I shift this digit towards left, then it will become -3. That means I'm going to shift one bit towards left. Then I'm going to subtract. Now, if I consider here, I have 3 and here also I have 3. Now, I'm going to perform subtraction. See, I have 0.5452 E3 minus 5424 E3. So, my both the exponents are same. So, I'll write E3 as it is. Then I'm going to subtract. 12 minus 4, it is 8. Remaining 4 minus 2, it is 2. It is 0. It is 0 and point. Okay. So, I'm going to get 0.0028 E3. Now, to make it normalized number, what I'm going to do? I'm going to shift this number towards left. That is 0.28 E3 minus 2. Why it is minus 2? Because I'm going to shift towards left. So, it is nothing but the decrement of power. Now, the final answer is 0.28 exponent 1. See, you can cross verify. So, both are same. Now, errors in numbers. So, dear student, when I perform addition, subtraction, multiplication or division, I may get errors. And what kind of errors? How to handle the errors? All those things we are going to study under errors in numbers. So, there are 3 types of errors in number. How many types of errors in number? 3. One is absolute error, relative error and percentage error. So, what are the 3 types? Absolute error, relative error and percentage error. So, what is absolute error? It is defined as the absolute value. So, what is absolute value? That's nothing but the magnitude of the difference between measured value and true value. So, dear student, in the question, you're going to get the actual value and the true value. And whatever the difference I'm going to get between the measured value as well as true value is known as absolute error. Now, what is relative error? It is defined as absolute error. So, relative error is nothing but the absolute error, but it is relative to the size of the measurement. So, it is relative to the size of the measurement. So, here I have the formula for absolute error. So, error is equal to, that is actual value and the absolute value. So, what is error? That is, error is equal to actual value, that is the specified value and the absolute value. And absolute error equal to EA equal to M1 minus M2. So, what is M1 and M2? M1 is nothing but true value and M2 is nothing but absolute value. As we know, relative error is nothing but the absolute error, same formula, divided by M1. It is nothing but EA divided by M1. So, where M1 correct value of a variable. So, M1 is always correct, that is exact value. M1 is nothing but exact value. Then what about M2? Here M2 is nothing but the approximate value. So M1 exact value and M2 is nothing but approximate value. Then the third type here is percentage error. That is EP equal to 100 into ER. So what is ER? That is nothing but relative error. Anyway, dear student, let's understand the type of errors one by one with the example. See here, student, I have the problem that is if x equal to 2.536 and find out the absolute error as well as relative error. And what is the condition they have mentioned? One is when x is rounded. So when x is rounded, another one when x is truncated to 2 decimal digit. So what is my first condition? I have the solution. What's my first condition? When x is rounded. So dear student, if I consider what is x, x equal to 2.536. Okay, suppose if I round 36, after 36, what is my nearest number? That is 40. It is 2.540. Okay, it is 2.540. So, when I round the number, I am going to consider 2.54. So, what is M1? Here, M1 is nothing but the exact value. So, M1 is exact value. Then, what about M2? M2 is nothing but my approximate value. Now, what is the formula? That is absolute error equal to magnitude of exact value minus approximate value. So, I am going to get minus 0.004. So, which is the magnitude. And when I take the magnitude, this minus will become positive. So, I am going to get the answer 0.004. Now, in the question, they told me to find out relative error. Then what is the formula? That is absolute error divided by exact value or true value. I have the absolute value and I have the exact, that is current value. Then when I divide, I am going to get 0.0015. Now, if I truncate in the sense what? I want to truncate 2 digit. So, here I want to truncate 2 digit. Now, M1 is nothing but my true value or actual value. Then what about M2? I want to truncate the number. I want to truncate 2 number. So, I am going to truncate only 2 number. When I truncate, my number is 2.53. Now, I have the formula that is, first I want to find out absolute error. I want to find out absolute error. Then, I have to find out relative error. After finding out relative error, I want to find out the percentage. Okay, so according to the question, they have mentioned I want to find out the absolute error and I have to find out the relative error. So, dear student, this is the way I can able to find out the value. When I subtract, I am going to get some negative value. I am going to get some negative value. So, what I am going to do? When I take the magnitude of that is nothing but the mod of that, I am going to get the positive value. Then, to find out relative error, I have the formula absolute error divided by M1. Okay, and when I divide that number, I'm going to get 0.00256. Now, dear student, my second question is, if pi equal to 27 divided by, that is 27 divided by 7 is approximated as 3.14. Now, find out absolute error, relative error and relative percentage error. So, when I divide 24 by 7, I'm going to get 3.1428. So, this is my M1. Then what about M2? M2 in the question they have mentioned there is nothing but the approximate. That is nothing but 3.14. So what is M1? That is the exact answer or the true value. Then what's the formula? EA equal to mod of M1 minus M2. And when I subtract, I'm going to get this result. Then what is ER? ER is nothing but EA divided by M1. So what is M1? M1 is nothing but 3.1428. And when I divide, I'm going to get this result. Then what is the relative percentage error? That is 100 into ER. When I multiply relative error with 100 and whatever the value I'm going to get, that is nothing but my relative percentage. Now I'm going to have my third question, that is the number x equal to 37.46235 is rounded off to 4 significant figures and compare absolute error, relative error and percentage error. So, what is the exact value? That is my given M1. So, M1 is 37.46235. Then what about M2? Here M2 is, in the question they have mentioned that rounded off to 4 significant figures. That means I want to round this number to 4 significant digit. When I round this fraction, it is 4600. So I have 37.4600. And when I subtract, I'm going to get this output. What about relative error? That's nothing but absolute error divided by M1. And when I divide, I'm going to get this result. Now, dear student, I want to find out percentage error. Then what's the formula? 100 into relative error. And when I multiply, I'm going to get this value. Now, I'm going to have my fourth problem, that is find EP. That is percentage error in absolute representation of 4 by 3 divided by 1.33. So what I want to do, I just want to find out percentage error. Now, what is my M1? This is my M1. Okay, so what is my M1? Here M1 is nothing but 4 divided by 3. So this is my M1. So what is my M2? That is nothing but 1.33. Now I want to find the solution. First I want to find out absolute error. What's the formula? Mod M1 minus M2. When I subtract these two, I'm going to get 0.0033. Now, to find out relative error, I have the formula absolute error divided by exact value. I have the exact value 1.333. And when I divide, I'm going to get 0.0024. And at the end, I want to find out percentage error. Then what is the formula I have? That is 100 into ER. What is ER? That is 0.0024. And when I multiply, I'm going to get 0.24. So this is the way I can able to find out absolute error, relative error, as well as percentage error. Anyway, dear student, in my today's session, I started with how to add floating point numbers, how to subtract floating point numbers. Along with that, I have discussed the different types of errors in floating point numbers. Anyway, dear student, in my next session, I'm going to deal with the next chapter named finding the roots of equation. Anyway, dear student, let's meet in the next session with the new chapter, that is roots of a equation. Until that, keep watching and keep learning. Thank you.